We'll add you guys back in.
Minus 1 theory.
Oops. All right. Are we live? Oh, yes. You ready? No. All right, everyone. Welcome back to another installment of Discovery Live Ask a Scientist. Once again, my name is Ben Gondres, and I am the Dome Theater Manager at the Fort Collins Museum of Discovery. And it's my pleasure to be able to host this program and to gather these scientists together so that you can ask your burning science questions. So this evening, we have a couple different panels. Our first pair of scientists are going to be two geologists right here in Fort Collins. And hopefully we're going to get to talk a lot about some local geology. There's lots to discover there. And if you have questions, don't forget you can leave them in the comments below and we will see those and be able to answer them for you. And after that, we will have two paleontologists from the Denver Museum of Nature and Science who have had a recent discovery that they, I'm sure, would love to talk to you all about. Yeah, we will get to them at about 5:30. So at this time, I'm going to go ahead and get our first two scientists on the call with me here. So welcome, Herb and Dave. Welcome, guys. Good to see you again.
Hi, everybody.
Thanks for having us back.
Yeah.
This is nice.
Awesome. Well, yeah. Well, as I said before, you guys are geologists. So why don't you just start off by taking a little bit of time and just introducing yourselves and telling us a little bit about what it is that you do in the field of geology. So Dave, why don't you go ahead and go first?
Okay, well, I got a bachelor's and master's in geology, and I went to work for energy exploration companies, big names that some of them don't exist anymore. What I did in the beginning was field work, looking at drill cuttings, looking at rocks, doing mapping up in Wyoming, down in South Texas. When I finished with some of that, I got a different assignment and I worked in New Orleans and only drilled wells that were below the sea. So there wasn't any field work to speak of, but we looked at the cores that came up from the drill rigs. I found some oil and gas. They moved me to the Rockies. I worked every state in the West looking for oil and gas. I worked in Alaska as well. Field work in the Brooks Range, in the Arctic National Wildlife Refuge, the Yukon of Canada. And got to understand a lot about the Rockies. Most of the work I did was field-based at first, coupled with looking at the drill holes that had already been completed by others. I did that for about 20 years, and then I went back to school, became a civil engineer, and have focused mostly on groundwater-related issues since then. That's
Excellent. Thank you so much, Dave. And Herb, why don't you introduce yourself?
Okay, my name's Herb Saperstone, and well, I also, like Dave, I also have a bachelor's and a master's degree in geology, and I kind of front-ended my career during graduate school. I worked for the U.S. Geological Survey, and I would like to say, classically trained with these old-timer geologists, and we would go out into the field and we would map rock layers, using hand instruments and topographic maps. We didn't have any GPS. We had nothing digital. And so that's how we went around and described all the geology of areas. I also worked in energy, in fuels such as coal, and a little bit in oil and gas. And eventually I kind of found my way into doing more educational stuff in earth science. And I worked for a number of years writing and producing earth science films for junior high school kids. And so that took my career off into a more of a sort of education and outreach direction with respect to earth science, and worked in the Poudre Schools District for a number of years. And now I'm retired, and I like to do a lot of, I was enjoying taking groups out on hikes out in the foothills to learn about our wonderful landscape here. But now we're doing something like this, which doesn't take the place, but it sure helps bridge the gap. So I'm happy to be here and talking about all things geology.
Excellent. Thank you so much. So I guess, Herb, you seem to be sitting in a pretty picturesque location. I'm guessing that's Horsetooth Reservoir behind you. And I think there's a lot of really interesting geology around Horsetooth Reservoir. So could you maybe tell us a little bit about some of these formations and things that we see surrounding the reservoir?
Sure. So yes, it's not a virtual background, which it could be, I suppose. And I'm a little dark because it's all backlit. But anyway, the Horsetooth area is, and people may or may not realize that Horsetooth Reservoir is a man-made or human-made body of water. It was filled in the 1940s as a way to sort of capture and store water that we really need for all the agriculture and the growing economies during that time. So underneath Horsetooth is a valley that's made of very soft rock called shale and siltstone. And then, of course, on the sides of Horsetooth, we have what we call more resistant rocks. In other words, they're resistant to erosion and weathering, so they stick up more. And so that's where you get the big red layers and the tan layers. And so those are also the same layers that we see when we drive along some of the western north-south roads in Fort Collins, and we can see what we call the hogbacks. And the A, of course, is the most iconic symbol on a hogback. And of course, that ridge is completely made of a tilted layer of sandstone or sedimentary rock that's been tilted up during the formation of the Rockies. So essentially, Horsetooth and all the areas have these sedimentary layers that we now see that are uplifted and put into that position over millions of years.
Excellent. So we've got an audience question here for you guys. And Sierra would like to know, what's the best thing about being a geologist in Colorado in particular?
I can go first quickly.
Sure.
You can see the rocks. If you came from any other part of the country or did field work any other part of the country that has trees, shrubs, rainfall, you would be walking in knee-deep, chiggers, grasshoppers, rattlesnakes, and in Florida, alligators and everything else. The good thing about out here being that it's arid, there's very much less vegetation. You get good what are called exposures, where you can walk right up and see layer after layer of the rock, feel them apart. You can find the fossils. You can see the ripple marks. You can tell pretty quickly what kind of rock it is and start understanding how it formed.
Interesting. Yeah, so you guys have both talked about layers of rocks, and I think, Herb, you even mentioned uplift. Can you go into that a little bit? And why is it that we see layers of rocks like that? And what exactly is uplift, and how does that work?
Yeah, so sedimentary rocks are one of the three major rock types, and we hopefully we learned that in grade school. But if not, sedimentary rocks are formed of loose sediment that's been laid down mostly in horizontal layers, with the oldest layers forming at the bottom and then the youngest layers forming at the top. Metamorphic rocks, which are rocks that have changed from a different type, whether they are sedimentary or igneous, which is the third type. Those are rocks that are formed deep below the Earth's surface, or sometimes at the Earth's surface, where rock is molten or in a liquid state. Of course, it's very hot and it cools. So the sedimentary rocks around here accumulated over time in sort of this layer cake fashion, again, with older rocks forming at the bottom. And everything is more or less parallel to the Earth's surface when they form. But at some point, there are forces, tectonic forces, such as gigantic plates that are moving around in the Earth, and they do cause these rock layers to be disturbed, and they can be uplifted. In other words, they can be pushed up into a different orientation, and that's what happened here about, well, between 80 and 50 million years ago. We had an episode of what we call mountain building, and those flat layers are now not flat anymore, but they are tilted as the core of the Rockies were tilted up. And so that's why we have that interesting configuration and orientation of those once flat layers.
Excellent. Thank you for that explanation. That was really great. So I think you guys, Herb, I think you brought some samples along. Do you want to show us anything in particular and tell us about where we might find something like the sample that you brought?
Sure.
Yeah.
Well, let's start with something like this. And if anybody's out there that wants to sort of make a comment on what they think they're looking at, feel free. But basically, these are fossil ripple marks. Oh, I lost my light.
Uh-oh.
Oh well. Anyway, these are formed. They can form in a number of places, but these are formed in shallow water. If anybody's been to the beach, even here at Forcetooth, we can see ripples forming right along the shoreline where where the water is moving across and moving the sediment in the water into ripples like this. And so this is formed. This is found around Horsetooth. It's very common. We can find these in some of those red sandstone layers. And then only one other thing I'm going to show you is a fossil, but there'll be more of this in the next session. And this is a fossil clam that's formed in a unit called a Pierre shale, and that's a younger rock that's actually found out in the plains area, not right here in the foothills. And so this is a clam. It's now been filled in with sandstone, so we're looking at a cast of this instead of the actual shell. There's no shell material left. So those are two examples of sedimentary rocks that one could find around here.
Excellent.
A key point to bring up when you see something like that is they are indicators of the environment that the rock was created in. The ripple marks tell you it was shallow, fairly shallow water. The clam obviously had to have oxygen to stay alive, so it was in oxygenated water. It had to have food, so it was near to a location where there was, in the case of clams, they filter minute particles out of the passing currents, but they're not found in the extreme depths of the ocean. There's nothing down there that they would have to eat. So you can tell a lot about the environment, and that's the kind of things geologists are really excited about when they find. And I think our following discussion with the paleontologists, they went through rock types trying to find ones that would be the host to the kind of animals that they were looking for.
Excellent.
That's right. And only sedimentary rocks give you that sort of clue to the past, in the sense that if you're dealing with igneous and metamorphic rocks, of course, you're dealing with more of an abstract origin because they form out of sight, way below the Earth's surface, or sometimes fairly close to the Earth's surface, and we're kind of guessing. But with sedimentary rocks, we absolutely know that a clam formed in a shallow, let's say, ocean, or a ripple mark formed at the edge of an ocean or in a stream. So that's just a little bit of a way to do this detective work in a way that makes sense.
Yeah, so it's my understanding that this area was actually once a shallow sea. And are those fossils remnants of that shallow sea existing here?
Yes.
Go ahead, Dave.
Excellent.
Yeah, well, one of the big economic impacts of the shallow sea, that it's called the Cretaceous Seaway, extended all the way up into the Mackenzie Delta in Canada in the central Rockies area. So here in Fort Collins, out into the plains, into Nebraska, all the way through Montana, parts of Wyoming, up into Canada, past Alberta. That seaway was a very shallow sea in a warm water environment, and it had a lot of, I would call it, changes through time, where it went up, it down, it changed in depth, but the sediments preserved a lot of organic material that later, when it got buried a little bit deeper, got cooked, to use a generic word, to create oil and gas. And that was a huge economic boom for the United States, for Canada, and it actually extends over into the same age rocks produce oil even in Middle East. So that's an important thing to understand about the environment that they were deposited in, and then find those rocks, and you're on your way to finding an economic deposit. And of course, we're now concerned about there's too much of that being produced at the surface, creating global warming by putting that carbon back into the atmosphere. But at the time, when we first were starting to discover that oil, 1865, roughly, right after the Civil War, from that time till now, it's been a central driver for the economic wealth of the United States.
Interesting. Excellent. So we've got another audience question here. What first got you guys both interested in geology?
Go ahead, Herb.
Well, I remember as a teenager having the opportunity to take a summer adventure. This was a group of kids that we were fortunate to do this. We got to go on a traveling camp, and I grew up in the East Coast, so we bussed all the way out west, visiting all the national parks, and I'm pretty sure that the group leader, because I don't exactly remember, was a geologist, and so everywhere we went, I was just amazed. And how do we know this? What are we looking at? And I still have, to this very day, I have slabs of rocks, fossils, that I still have from when I was 13 years old, and we did this cross-country trip. So, and I was hooked from then on. That was the beginning of my love affair with geology and earth science.
Excellent. Thank you. How about you, Dave?
Pretty similar. My sophomore year of college, they said you have to take another science, and I at the time thought I was going to be a chemical engineer, and the classes that I wanted to take were filled up. So somebody said, "Oh, there's this one in geology that you can take, and it qualifies for the other science." And I said, "All right, what's that?" I thought it meant geography. I was a little confused for the first couple of lectures, but then I found out what was really going on. But the fun part was, the professor was the chairman of the department, and his name is Ray Murray. He became the state geologist of Montana later in his career. But the very first class, he told us what we were going to study, and then he said, "All right, everybody up and out the door." We went down to the river that was right next to the campus. He rolled his pants up, and he was showing us how ripple marks were made by dumping blue dye into the water. And I thought, this is a lot more fun than sitting and listening to somebody talk. And that weekend, they had a field trip. I went, I collected rocks. My roommates thought I was nuts, but it stuck. It stuck for till now.
Yeah, so. Awesome. Yeah, I think I feel like that's a pretty common thing for kids, is to collect rocks. And there's something just intrinsically interesting about rocks and crystal formations and all these different varieties of things that you can find just laying on the ground. So yeah, I think that's pretty cool. Yeah. I had another question and I just spaced it. What was it? So you guys both talked about your backgrounds a little bit in terms of, energy exploration and oil and gas and that kind of thing. But what other kinds of career paths might there be in the fields of geology if somebody wanted to go in a different direction?
Well, there's volcanology, that people study the activities that go on in places like Iceland or Hawaii, where there's active volcanism right now. Everybody's seen the movies where the volcano blows its top and it wipes out the villagers and everything, and trying to predict And they can do a little better at predicting now because of the geosensors and watching uplift areas where when lava gets near the surface, it expands, and that rising of the height of the volcano gives you a fair warning that there may be something bad could happen with the people. Also, and there's the ash that gets up into the air and causes problems for jet airplanes and things. One other career is industrial minerals, just something simple stuff like limestone that can be ground up and made into cement, which then mixed with sand and water becomes parts of our buildings and highways and such. That finding the correct kind of limestone that will work as an efficient cement, doesn't need to be processed too much, is there's a little bit of a trickery there in the sense of knowing where to find it.
Yeah.
Certainly gem exploration, emeralds and diamonds and things that people always hear about. There used to be a lot of gold and silver in the Rockies. Those were careers. And I think just understanding how the earth changes, what global warming has happened in the past is probably an indicator of what will likely happen in the future. And so understanding the processes that causes the atmosphere to change, the chemistry of the ocean to change, the health of the animals that live on the ocean or on land because of those changes, that's all been recorded. It's all been studied. There's places that it needs more study. There's a career there.
Yeah.
Cool.
A more sort of esoteric and maybe interesting career path, which I think maybe just a few people get to do, is looking at things like planetary geology. And I know, Ben, you're a big fan of this sort of thing.
Yeah.
But you know, all the Martian, for example, all the Martian planetary rovers and a lot of the crafts that are circling and doing a lot of remote sensing of the surface, they're finding so many interesting similarities to things that we see here on Earth. And then there's a lot of chemistry that they're figuring out sort of remotely. And I think that as time goes on, you know, that blending of Earth science and planetary science is going to become something almost indistinguishable from each other. And I just think it's an exciting field to sort of think about our universe, and certainly our solar system is so similar. There's so many similarities to what's happened here on Earth, and we can learn a lot about the history of our planet by studying other planets too. And that's a whole nother topic. But it's a fun one to think about.
Absolutely, it is. Yeah, and interestingly, I just connected the dots between something that you said, Dave, about finding the right minerals and different things to make concrete and building materials and whatnot. And I mean, if we were to ever actually make it to Mars, we would probably be needing to do much the same thing, finding materials to be able to use there on the planet, because every rocket ship that we send can only carry a limited amount of capacity of building materials. So ideally, I know I've seen 3D printers that use the Mars regolith to create things and different things like that. So I think that's going to be a very important thing when we do start to explore other planets and things like that. So that's pretty cool that you can kind of start here on Earth, but maybe someday in your career, especially if you're young in your career, I mean, you could be going to Mars. I don't know. Who knows? That could be pretty cool. Excellent.
So I just quickly wanted to bring back the industrial minerals to something right here. So this is a sample of gypsum, and this is a mineral that's very soft and is a very important locally derived industrial mineral. And Devil's Backbone, which is just outside of Loveland here, has an old gypsum mill, because some farmer back in the late 1800s discovered that his irrigation ditch was disappearing underneath his farm. And it turns out this mineral is very soluble. In other words, water can dissolve it away very easily. And they came across a huge, vein is a great word, but deposit of gypsum, and they mined it for many, many years, and it was a huge economic boon to this whole area for many years. And of course, gypsum is still mined in the area, but this is something that people can visit and look at, and they can actually see the layers of gypsum up there as well. And there's plenty of it in the foothills. So I just wanted to bring that back to sort of the local geology.
Yeah, that's awesome. Thank you for doing that. And speaking of local geology, we have another question from our audience here. We've got a 10-year-old that wants to know where they can find some fun rock hunting areas in our local area here.
Go ahead, Herb.
Well, you don't have to go far. Now, you just have to keep in mind that a lot of so if you go out on the county's open spaces or the city's natural areas, you really can't collect rocks, so that you're probably limited to places that are private property, or maybe there's some other lands where rock collecting is allowed. So you just have to check before you go out. But you can assemble a whole collection of sedimentary rocks, igneous rocks, metamorphic rocks, put them in little egg cartons, and start collection there. And then there are things like gypsum and little fossils that you might find. But you have to know where to go, and you also really need to know the local rules about where you can collect and not collect. But I would say there's so many places you could go. Yeah. Yes, and there are resources such as this book and others.
Right.
Roadside
I
geology.
strongly recommend, if you have an interest that will last more than a couple of hours, look into getting this book. It's called The Roadside Geology.
Yep.
There's places along the road cuts up in the Poudre Canyon, the Thompson Canyon, where the highway department has widened the highway and pushed back the cliff so that the rocks don't fall off in the spring melt and crush cars. And there's all kinds of boulders, and a special kind of rock that's a lot of fun for a beginner especially is called a pegmatite. Pegmatites are the injected high-end, they're not even from lava, it's a granitic melt. It was a separated part of the rock that's come back up to the surface, and they have micas and big feldspars, big pink and orange feldspars, gray quartz, and of course, that was what people chased in the old days when they talked about going after a vein of gold. And so you'll find that those rocks, especially the micas, are very sparkly and interesting to look at the beginning. My caution is, if you're doing roadside geology, maybe wear a safety vest. You can get them at Home Depot, some bright orange. And if it's a group of people, make sure somebody's watching for cars, because multiple times I've stepped backwards and heard skids, and I'm lucky to be alive.
Yeah. Maybe have someone watching your back a little bit, so you don't accidentally.
Somebody's got to be a traffic patrolman, and then the kids can bang on the rocks on the side of the road. And actually, the highway department would probably enjoy that you took away something.
Help them make that cut a little bit more.
Get the boulders away. But it is, and also watch for small crawly things, scorpions and snakes.
Yeah, good call. Excellent. Well, you guys, let's see. I had another question, and this keeps happening to me.
So the pegmatites you were talking about are common. Yeah. Granite countertops is what Dave was referring to. So if the word pegmatite doesn't make sense to you, many countertops, kitchen countertops or bathroom countertops, are made of that same stuff.
Interesting. Yep. That's very cool. So yeah, we've been talking quite a bit about local geology and uplifts and different things. It seems like this region was at one point perhaps pretty geologically active. Do we have any risk of earthquakes or volcanoes or anything like that here in Colorado?
Slick and slides, Fred. Show them.
Well, the answer to the question about today is the risk is pretty low. It's a pretty cold, maybe that's a good word. It's not very active. Think of California and the San Andreas, or think of the Pacific Northwest with all their big volcanoes like Mount St. Helens. It's not like that here. Okay. It was 30 million years ago, but it isn't. But there is something that you can see when you hike around Fort Collins. Do you see these linear features on here that looks kind of polished? Well, this is a piece of sandstone that was part of a fault. It's actually both sides of this. This is called, the technical term for this is slickenside. It's a German word, I guess. And I wish I could give, yep, you can see the striations. And so another piece of sandstone was rubbing against this along a fault, which is a fault is a break between two rocks where two opposite sides of the fault plane, rocks move past one another. And not only happens when you have mountain building and uplift like I was describing earlier. So you can find these here in Fort Collins or actually anywhere in the foothills, but they're old. They date back, like I said earlier, about 50, 60 million years old. So those processes have long stopped, but the evidence for them, you can look right at the ground where you're hiking.
Excellent. Awesome. Well, we're just about out of time talking about geology. But thank you guys both so much for being on the program once again. It's always a delight to have both of you here and to just chat about rocks with you. So yeah, hopefully you guys have a good rest of your evening, and we will see you at the next one.
All right.
All right.
Thanks, Ben.
Guys.
Thank you, Ben.
And for anyone watching, don't go anywhere just yet. We do have our two paleontologists coming right up here. So here we have Tyler Lyson. Hi, Tyler. And Ian Miller. Hello, Ian.
Hello.
Awesome.
Hello,
well,
everybody.
welcome to the program. This program is Discovery Live, Ask a Scientist. And the way that this works is basically I'm obviously moderating here. And hopefully people will be leaving us comments on Facebook. We're live streaming on Facebook and on YouTube. And I will relay those questions to you guys and we'll get some answers. But why don't we just start off by getting some introductions from both of you? Why don't you tell us a little bit about who you are and what you do as far as paleontology is concerned? So Tyler, you're to my, let's see, that side. So why don't you go and start us off here?
Sure. So my name's Tyler Lyson. I'm a curator of vertebrate paleontology at the Denver Museum of Nature and Science. So I'm one of the scientists there. I've got the lucky job of being a paleontologist. So I study ancient life. I specialize in Earth's last mass extinction. Basically the last million years of the reign of the dinosaurs, and then the first million years of what happened next, the age of the mammals. So I specialize in that. And then the other thing I study, which is a little bit different, is and much, much older in time, is the origin of turtles. Who are turtles related to? How did they get their shell? When did they get their shell? Why did they get their shell? You know, all those fun Dr. Seuss-like questions.
That sounds really, really fun to study. Excellent. Ian, why don't you go ahead and introduce yourself?
All right, thanks, Ben. My name is Ian Miller, and I'm also a curator at the Denver Museum of Nature and Science. I'm a paleontologist as well, and my specialty is fossil plants. So I'm actually what you would call a paleobotanist. And so I collaborate with Tyler a lot. We have a lot of joint projects going on. So I also study that time period right before the extinction of the dinosaurs and the recovery of life after the massive asteroid hit the Earth and wiped everything out. So I study that time period plus a little bit earlier. So I'm not quite as old of rocks as Tyler and the origin of turtles, but I look at the origin of flowering plants and how they evolved through the Cretaceous. And in particular, a time period about 10 million years before the extinction of the dinosaurs, when we sort of see an expansion of flowering plants around the world, and the forests are pretty different than they are today. There's a weird mix of archaic things and new things, sort of right there at the end of the time of the dinosaurs. So that's my area of expertise.
Excellent. Thank you so much. And of course, thank you both for being here for the program. Excellent. So, we talked a little bit about in the previous segment, we had a couple of geologists on, and we were talking a little bit about the inland, the shallow inland sea that used to cover this area. And could you guys talk a little bit about that as well, and give us kind of your insight into what that might have looked like and what lived there, and anything that you might know about it, which I'm sure is a lot.
Sure. Yeah. I guess I'll go first here.
Sure.
So the Western Interior Seaway stretched from the Gulf of Mexico all the way up to the Arctic Sea. From about 90 million years ago until about 70 million years ago. And Colorado was underwater most of that time, probably a few hundred meters, 200 meters, something like that. And that sea was just filled with remarkable animals, including, all the vertebrates, which Tyler could talk a little bit about, and incredible invertebrates like ammonites and nautiloids and huge inoceramous clams and that kind of thing. And it's interesting. We study a lot of the rocks right before that happens and right after. So here in Colorado, we see when the seaway sort of drowns this part of the continent, there's a beach that is in front of it. So you can imagine the seaway sort of advancing over the continent over millions of years. And that that beach is called the Dakota Sandstone. And it's filled with all kinds of amazing fossils, including lots and lots of fossil plants. And the retreat of that seaway, some 20 million years later, has a beach that follows it back out as the seaway goes away, and that's called the Fox Hills. And both the Dakota and Fox Hills are right here along the Colorado Front Range, and so you can see that beach of the set and the offset of that ancient seaway.
Cool. Yeah, I always like to think about that. This giant sea that split North America in two, and how we're clearly landlocked now, but I mean, Colorado was once beachfront property, right?
Yeah.
Of course, it was underwater, and then it was beachfront property. And it was because of that beachfront property that Ian was talking about that we have all of these amazing dinosaur ecosystems right at that critical interval of time, that both Ian and I study right before dinosaurs go extinct. And then the area also preserves that time right afterwards. But this ocean was so amazing because you had just these amazing creatures living in it. These giant sea turtles, much bigger than anything we have alive today, the size of small cars. So you can imagine these little, car-sized turtles just maneuvering around this ocean. You had, of course, like the mosasaurs, sort of like a big Komodo dragon, but in the water. The long neck, the Loch Ness monster-like things, right? The plesiosaurs, all of these things just living in this amazing ocean. So pretty cool to think about, and all right here in Colorado.
Yeah, it's amazing. If only it was still beachfront property, that would be that would be pretty cool. Although I'm sure it'd be even more expensive than it is. But
we wouldn't be living here.
Yeah. So speaking of all the amazing things that you guys and other paleontologists have found along the Front Range here in Colorado, you guys just made a pretty amazing discovery. And I'm sure you want to talk about it some. I'm sure you've talked about it a lot. But a discovery just down in Colorado Springs, if I'm correct, of some mammal fossils and some plant fossils as well. So you want to just give us the quick summary of what that discovery was and why it's so exciting?
Yeah, sure. Yeah, we are so excited that we made this discovery. We made this discovery right outside of Colorado Springs. I mean, it's literally inside the city limits of Colorado Springs. That's how close it is. But the discovery is from right after the giant asteroid wiped out the dinosaurs. And it's this critical interval of time when the modern mammals, including our own group, the primates, they start to really take off. All placental mammals, they start diversifying and really radiating. Lots of different plant groups sort of have their origin right after the dinosaurs go extinct. Because you can imagine, right after that asteroid struck, it just wiped the slate clean. It was a whole new world for life to take off in. The unfortunate thing about that was that we didn't have any fossils. We didn't have fossils from that critical 1 million years after that mass extinction. And so there we were, Ian and I have been talking about finding fossils from this interval of time because the rocks of the right age are here in Colorado. And we thought about, this is where we could make a big splash. If only we could find the fossils. And I never would have guessed that it would have been inside the city limits of Colorado Springs where we made that discovery. But we did, and we found just amazingly complete plants, which Ian can speak to. But we also found whole mammal skulls, and in some cases skeletons and crocodiles and turtles, this whole ecosystem that inherited the Earth after the dinosaurs went extinct.
Excellent.
Yeah, and I don't have a ton to add to that, other than it is the origin of the modern world. Everything that's alive today outside our windows has an ancestor that had to survive that incredible event 66 million years ago. And the progenitors to some of the most important plants on the planet today have their origins, they evolve right at that moment. And one cool story is we found the world's oldest legumes in these deposits. And legumes today are the third most speciose, or third most diverse group of plants on the planet. There's some 20,000 species, tens of thousands of species of trees in the tropics. And they're second only to grains in terms of importance in terms of a food source to humanity. And they have their origins right after that asteroid impact. And the oldest ones are found here in Colorado, and in fact, right outside Colorado Springs. Well, literally within the city limits of Colorado Springs. It's pretty incredible.
You got to tell that discovery story too.
Okay,
right? I mean, come on, it's one of the best discovery stories out there. Yeah,
right, yeah. So we have this wonderful program at our museum, and maybe you guys have something similar at your museum, where we have teens come and work with us for the summer. We call them the Teen Science Scholars, and we take 20 to 25 kids. And these kids are, we really focus on groups that are underrepresented in the sciences to help promote these kids' passion in science and their future in college and beyond, and graduate school. We've even had some kids get their PhDs by now, since the program's been running for a little bit more than a decade. And so we pay them to come work for us for the summer. So they get a good hourly wage that helps them not have to worry about another job. And so 3 years ago this summer, Tyler and I had 7 or 8 of these teens with us. We had taken quite a large cohort that year. And this one student, Aeon Way Smith, she was pretty shy and didn't really know if she really enjoyed what we were doing, which was digging these gigantic holes and pulling rocks out and cracking them and looking for fossil leaves. And one of the things that's so cool about this whole project is that we had a film crew follow us the whole time. Once the discovery was made, we called a few people and they jumped right on it, and so they followed us. And so the crew was out there filming and doing some interviews in the quarry and that kind of stuff. And Aeon was in the quarry with me, and I was talking to the camera or something. And she started pulling on my shirt, asking me like, "What's this fossil?" And normally I have, I take tons of volunteers to the field and stuff, and people just show me there's lots of not very good fossils. So I just toss them over my shoulder and throw them down the hill. And that's certainly what I expected to see. And and I could just see it out of the corner of my eye, and it looked like a stick. It just looked like a fossil that wasn't worth anything. And then it caught the light, and it just had the telltale sort of bumps of a bean pod. And right there on camera, even with me telling her at the first round, I think that's a stick, she said, "No, I think you should look again." Was the oldest fossil bean ever found on Earth, and she found it on camera. And if you watch the show, you'll actually see that moment. And they did some interviews with her right afterwards, and
Nice.
it was pretty incredible.
I think they had to edit it out some of your excitement, right?
Yeah, exactly.
I just think that's so cool that one of the most important plant fossils found by a high school kid.
Yeah,
right. I mean, that's awesome.
Yeah, she was 14 at the time, and yeah, it is phenomenal. And discoveries happen all different kinds of ways and all different kinds of areas. And so this is just one great example of that.
Yeah. So there's a Nova documentary about this discovery, correct? Is that the film crew that was with you?
That's right. Yes, we collaborated with the Howard Hughes Medical Institute in collaboration with PBS Nova, and we put together a 1-hour documentary called "Rise of the Mammals."
Cool.
That you can stream now. So get on there and watch.
Great time to do it, right?
Yeah, exactly.
Yeah.
What else is going on?
Yep, exactly. So we've got an audience question here, and Sierra would like to know, what was the most surprising thing that you guys found in the Colorado Springs dig?
Well, certainly the legume was up there. And there are so many, and I think Tyler will be able to detail some of these bizarre early mammals that we started to find. But one of the things that was a big surprise, I mean, we had some hints, but we just nobody really had evidence for it before this discovery. And that was how the plants and the animals recovered in lockstep from the asteroid impact. And so And maybe that's not such a surprise, but there just wasn't evidence for it before. And so we saw major groups of plants showing up on the landscape, the walnuts in particular, alongside the legumes, and those being correlated with big changes in the body size and dietary habits of the mammals that we're finding.
Yeah, I mean, I think the fact that we just found amazingly complete fossils from this interval was a complete shock, because we weren't the first people that went out there. I mean, the Smithsonian was out there in the early 1900s. Our own museum had been looking for fossils out there for over 40 years. And we just thought, well, we should go have a look ourselves and see what we can come up with. And we just came up with this new way of looking for fossils, and we all of a sudden could start seeing these fossils everywhere. And I think that was the coolest moment when we cracked open that first rock, realized there was a whole mammal skull inside of it, and then looked across the landscape and just saw, you know, the special type of rock lying all over the landscape. It was really like kids in a candy store running around, cracking them open, finding mammal skull, turtle skull, you know, whole crocodiles.
Wow.
And one of my favorite is this big thing that we called the pig wolf. It's a big mammal that has a really unusual skull. It has a skull that's unlike anything ever before it or living today. Just the overall proportions of the skull. It's just a really bizarre looking animal. That's an animal called Eoconodon.
Excellent. And the special type of rock, I think, is called a concretion. Is that correct?
Yep, that's right. And a concretion is just a type of rock. You know, it's just a type of rock that forms around an organic nucleus. And that organic nucleus can be a plant, because some of these concretions have lots of plant fossils. They can form around an invertebrate, like a little snail shell, or if you're really, really lucky, around whole mammals, turtles, crocodiles.
And concretions are pretty common in marine sediments. So if you're an ammonite hunter or something like that in the shales here across Colorado or Wyoming, you search out concretions and you crack them open and find a whole shell in there. But that preservation style is not very common, almost unheard of in these terrestrial settings. And so to have, you know, the heads of ancient mammals preserved in concretions like they were ammonites is, well, nobody had ever found that before. So that was pretty incredible.
That's amazing. And speaking of discoveries within city limits, I think you guys also were part of a dig of a Triceratops in Highlands Ranch. Is that correct?
That's right.
And that was just a construction crew that ended up finding that fossil?
Yeah, I mean, here in the Denver Basin, the construction workers actually find a good chunk of the fossils, because they're out there, they're moving the dirt around, building things, and it just takes that curious person, you know, to pick something up and be like, huh, what's this? And that's what happened. A construction worker picked something up and they gave us a call. And I went out there the next day, and I could tell by the pictures that there was a dinosaur and that it was going to be fairly complete, but didn't really know how complete until you start digging. Went out there and had a look, and sure enough, it turned out to be a pretty complete Triceratops. We're still working on the cleaning portion of that project, but it's got a good chunk of the skull and some of the limbs, some of the pelvis, quite a few ribs. So the construction workers, they get to have all the fun here in the Denver Basin.
Nice. And with that in mind, what should people know if they, you know, happen to come across a fossil, or how should they handle that sort of situation? Should they collect it themselves, or call Denver Museum of Nature and Science?
Or you guys? Yeah. You know, it kind of depends on the situation. You know, and depends on the type of land too. So here in the United States, if you're on state or federal land, many fossils are protected. That's not necessary. So on federal land, you can collect plant fossils and invertebrates. But on state land, you need a permit for fossils, and on federal land, you need a permit for vertebrate fossils. And but there are many places that you can go and collect fossils for your own, you know, collection. And I think both Tyler and I would encourage that. I think it's a really wonderful thing to do, and a great way to engage with the outdoors and with science and with our own history and that kind of thing. But sometimes fossils are really special, and they really tell us something important about our collective history on the planet. And those, it is good to bring in a team from a museum or a university, and that's often the case with a dinosaur or something like it down in Colorado Springs. So it takes, so if you have any questions, reach out to a museum. So we field questions all the time. People send us photos that just take a shot on their phone and email that to us, and we let them know what they have. And a lot of great discoveries get made that way.
Yeah, I think the only thing I would add to that is to leave it in place. Take a picture of it, because the context is generally really, really important. So if you can, safely leave it in place, then that's really important.
Yeah. If you see a dinosaur peeking out of a rock or a hillside or something like that, definitely picture instead of whacking at it with a hammer. Yeah. But you can do it with us. We'll teach you how to do it. We'll all go out there together. We always bring the discoverers into the process. So
awesome.
Yeah,
that's good to know. We've got another question from the audience here, and it's kind of related perhaps, but what do you wish people knew about paleontology?
There's a couple of things. I'll just say the one, people always think with paleontology, it's like that Jurassic Park scene, right? Where the helicopter's coming in and they're like, oh, cover up the velociraptor hand. It's going to blow away, because they're using a brush, right? They're just using a tiny little brush to brush off this articulated, curled up hand. And paleontology is not at all like that. I can count on one hand how many, articulated or fully preserved dinosaurs that I found. Usually we're out there with jackhammers and picks and shovels and rock saws, where it's pretty backbreaking work. And a lot of that detailed work happens back in the lab. So I know that's just, I guess, a common misconception that a lot of people have, that when they come out with me, they expect that Jurassic Park scene. And sorry, folks, it's not going to happen.
Yeah,
you're going to find something cool, so that's fun. But it's just not that.
Yeah, I think that's a good point. And I would just add that even though we're not finding those articulated velociraptor hands and things like that, that paleontology is endlessly exciting, and you never know what's around the next corner, and it drives us to work 18-hour days in the blazing sun and that kind of stuff, with bugs biting and all that kind of stuff. But it's amazing to be able to reach back into the past and understand something about how life got to this moment, and understand something about our collective history here on the planet. Is really, really remarkable.
It's our only direct window into deep time is through the fossil record. So it's pretty powerful. It's a powerful data set.
Yeah. Awesome. We've got another audience question here. Barbara would like to know, is there any evidence of saltwater-based fossils in the Front Range?
Many. So we'll go back to those shales of the Western Interior Seaway. And so we find all kinds of incredible things up and down the Front Range. And in fact, sometimes that's most of the fossils that get reported to us. So we find lots of ammonites, the big coiled squid, and nautiloids, the straight-shelled squid, and lots of different kinds of clamshells and stuff. And then sometimes vertebrates, so like these long, plesiosaurs, these long Loch Ness monster kind of critters. And so those are all saltwater animals, and they're in the shales here along the Front Range. And those are the same shales that we frack for gas, and to create local reservoirs to extract the gas. And so we're drilling down into those ancient sediments, and we're just pulling out the gas and oil from the plankton that was accumulating in that ancient sea. So there are literally millions, and in fact, if you count all those plankton and stuff, trillions upon trillions. That's not even a large enough number of fossils, saltwater fossils here on the Front Range.
Excellent. So really quickly, what excites you the most about the field of paleontology? And I think you've kind of touched on this a little bit already, but if you want to kind of go a little bit deeper into that.
I think for me, again, like Ian had said, it's the discovery, what you're going to find. And then also what I had said is like, it's the only direct window into time. That's really, really powerful. You, as a molecular scientist or developmental biologist, you can sit there and tinker with the genes and the molecules, the genetics, to come up with like these Frankenstein looking animals to maybe think about how evolution may have acted or how it may have worked. But the only way to test that is by looking at the fossil record to say, like, did an animal like that actually exist at one time in Earth's history? And we can only do that with the fossils. And so again, I think combining those fossils with the developmental data sets and the molecular data sets, we can answer some really big evolutionary questions.
And I'll answer that as well, but I'll take it in a totally different direction. I think this is one of the ways that Tyler and I get our jobs done is we work with community or citizen scientists and volunteers, and we both have worked with hundreds and hundreds of people. And some of the greatest discoveries in the history of paleontology are made by people without the advanced degrees. And so I would say one of the things that's really exciting about paleontology is that it's really accessible. And you can play a role in the sort of the grand effort to push the science forward without having the PhD and all that kind of stuff. And so I just encourage you to go find fossils and ask questions and read about them and learn something about the history of the planet through the fossils that are out there. And so it sparks the imagination, and yeah, it's super accessible.
Excellent. Thank you so much. So I'm going to just take a wild guess here, but I'm guessing that you guys have traveled to some interesting places in pursuit of some of these finds. Can you tell me about maybe the most interesting place that you've traveled or most interesting dig that you've been a part of?
I think I'll go first because I think Ian's is a little more exotic than mine. For me, it's been South Africa.
Okay.
Some of my work on early turtles, and here we go to what's called the Karoo Basin, and it's in the very sort of southern tip of Africa, in South Africa, and there we have rocks that are about 280 all the way up to about 170 million years old, and it's the best place in the world that preserves the biggest of all mass extinctions, and that's the Permian Triassic extinction. And it's got the best fossil record for that. And because, and not only that, but it has just amazing early proto mammals and turtles and animals like that. And so I think that's been the most fun that I've had is going down there and collaborating with a lot of my South African colleagues and learning a lot. I mean, they find fossils very differently down there than we do here in North America. And just a lot of fun.
Excellent. Thank you. All right, Ian, let's hear your exotic locale. Now I'm excited.
Yeah, well, for me, it's Madagascar.
Okay.
And I've been there twice. And one of the folks on staff at the museum, he's another vertebrate paleontologist. He moved to the museum about 3 or 4 years ago. He sort of semi-retired from Stony Brook University in New York. And in the early 90s, he discovered or sort of rediscovered fossils in Madagascar and started this unbelievable multi-decade paleontological project on the island of Madagascar. And the idea is to understand how the biota got to be sort of strange in Madagascar. So Madagascar is an island, and probably everybody's familiar with that. You might not know that it's larger than California. It's a huge landmass. It just looks small because it's sitting it's near the equator, so it's always it's not stretched out on our maps.
Right.
And it's also sitting right next to Africa, which is gigantic. And today, something like 95% of the species and 80% of the genera are unique to Madagascar. It's sort of one of the world's biodiversity hotspots. And Dave Krause, our colleague, really wanted to understand that. And so in the last decade or so, I've had the opportunity to go over there for a couple of 2-month trips each time. And it's just, it's so different than the worlds that we know here in the Western Hemisphere. I mean, there's a lot of sort of development and things like that haven't really reached Madagascar. It's still a very safe place to travel, and we would spend weeks on back roads and spending time with villagers and getting permission to go onto their tribal lands, look for fossils, and it's just it's sort of caught in time, and it won't be that way much longer. I mean, on my last trip, the amount of connectivity in which people have cell phones and can, reach the internet and things like that, which is a very good thing. They're getting access to education in ways that they never had before. But it is in some ways also a loss of this, all these old cultures and that kind of thing. And so, and it's just, you go over there, you're definitely going to get sick. I've gotten all kinds of strange tropical diseases that defy the doctors back here in the States, and eventually you just have to wait for 2 years until it goes away or something like that. And it happens to all of us over there.
Oh, no.
So but it's worth it. We find these incredible fossils that help us tell a story of this island biogeography and how life was sort of evolved in isolation there in Madagascar for tens of millions of years.
Excellent. That sounds super cool. All right, we've got another audience question here, and I think this might be our last question for the night, but Maya, who's 10 years old, wants to know what kind of fossils can be found in or near Fort Collins?
A lot. So the rocks there in Fort Collins stretch from about 300 million years ago all the way up to about 70 million years ago. So, and there are slices of time that aren't very well preserved, so you have gaps, but there are really important time periods that do have fossils. I don't have a great command of the fossil record right around Fort Collins itself, but there's got to be all kinds of marine fossils and lots of trace fossils, tracks, and ancient sand dunes, and if you're lucky, maybe even a dinosaur in some of these in the youngest of the sediments right there. So I think all of it's possible. It's just not so different than Denver, Colorado Springs, even Canyon City. We all share a very common fossil record. And there's a great book called Geology Underfoot by Lon Abbott out of CU Boulder, and he details all kinds of incredible geology and the fossils you might find here just along the Front Range.
Excellent. Yeah, I know in our museum, we have a cast of a plesiosaur that was discovered near Horsetooth Reservoir. And I believe you guys actually have the original, the actual fossil itself. So yeah, that was found right here near Fort Collins. So that's pretty exciting.
Absolutely. Thanks, Ben. Yes, you're absolutely right. And, but yeah.
Yeah. Cool.
You just got to get out there and look, right? I mean, that's the great thing about Colorado. There are tons of fossils from much of Earth's history right here. And that's just so exciting.
Yeah, it's pretty amazing. All right, guys. Well, thank you both so much for being on the program this evening. It was a real pleasure to get to talk to you both and get to ask you these amazing audience questions. I hope you guys have a good rest of your evening and a safe and healthy 4th of July. And hopefully we'll talk more with you again sometime soon.
Oh, we'd love it. That'd be awesome.
Yeah, thanks for having us.
Awesome.
Yeah.
All right.
All right.
Thank you guys
care,
so
you guys.
much. Yep. All right, everyone. Thank you all for joining us for another Discovery Live Ask a Scientist. Once again, my name is Ben Gondres, and it was my pleasure to bring this program to you. If you did enjoy tonight's program, please do consider making a donation to the museum. You can do that at fcmod.org/donate, and we would really appreciate that gesture so that we can continue to put on these awesome programs for you guys in this format. And once again, we do have a lot of different things going on all of the time. We've got virtual workshops, these live streaming events, all kinds of fun stuff, discovery boxes. So make sure to check out our website at fcmod.org to find out about all of those amazing things that you can engage in right now, even while the museum is still temporarily closed. Hopefully you guys all have an excellent evening, and as I told our previous guests, a safe and healthy 4th of July. And we'll see you guys at the next one. Thanks for coming. Bye.